Alright guys, so starting off, we're given the curve y is equal to 2x plus 1 over x, and point A when x is equal to a half. So what's the question here? Find the normal to C at A. Okay. Sounds simple enough, but what actually is a normal? Well, a normal is simply just perpendicular to the line in question, which means that if the tangent's gradient is 3, the normal's gradient is therefore negative a third. So great. All we need now is the gradient of the tangent. But hang on. We don't even have that yet, so how do we find it? That's where the derivative comes in. Our y value is 2x plus x to the negative 1, which means therefore that our derivative is going to be 2 minus x to the power of negative 2 if we apply the derivative function. Now if we plug in x equals a half, we get dy by dx is equal to negative 2. Perfect. That's the tangent's gradient. But be careful, because that's not actually what we want. Remember, the normal flips it, so our gradient is going to be 1 over 2. Cool. But now there's another catch. We need a point. And so at x equals a half, y is equal to 3. So therefore a is equal to a half 3. From here, we can simply see that the equation of our line must be y minus 3 is equal to a half x minus a half. Cleaning this up, we get 2x minus 4y plus 11 is equal to 0. That's the normal. Okay, so far so good. But here's where it gets messy. The normal is supposed to meet the curve again at another point B. But now the problem arises. How do we know where they meet? The easy answer? Simply make them equal. Let the curve equal the line. So, y is equal to 2x plus 1 over x, and 2x minus 4y plus 11 is equal to 0. Plug one into the other and we get 2x minus 4 times 2x plus 1 over x plus 11 is equal to 0. But wait, look at that. It collapses into a nasty looking equation. 2x minus 8x minus 4 over x plus 11 equals 0. Okay, now don't panic. If we tidy this up, okay, we've got negative 6x minus 4 over x plus 11 is equal to 0. If we multiply through by x, suddenly it looks way nicer, because we get 6x squared minus 11x plus 4 is equal to 0. Now, we've simply got a quadratic. So if we solve this, we get x equals a half, or x is equal to 4 over 3. But wait, x equals a half is simply just a again. We've already got that. So we need the other solution. X is equal to 4 over 3. When we plug that in, we get y is equal to 2 times 4 over 3 plus 1 over 4 over 3 is equal to 41 over 12. So therefore point B must be 4 over 3, 41 over 12. Okay guys, so for the next question we're told to find dy by dx at O and the tangent at O, given the curve and the line that you see in front of you. As you've probably guessed, this is actually quite easy. All we have to do first is just make the derivative more appealing, so we just multiply the x in, so we get x minus x to the power of 5 over 3, and then from there we just differentiate it, and when we do that we get 1 minus 5 over 3 x to the power of 2 over 3. Okay, Now lastly, if we plug in O is equal to 0, 0, wait, hang on. If x equals 0, does this even work? Let's check that quickly. Well, x to the power of 2 or 3 at 0 is just 0. So that's no problem. So what does that tell us? Well, plugging in what we know into our line equation here, we can just say that y is equal to x. That's what it comes down to. And that's the answer to the question. Alright guys, now it says, show that the tangent to A is equal to 2x plus 3y is equal to 2. Now we're told that A is equal to x equals 1, y equals 0. That's easy. But we need a gradient. Remember, because a tangent is a line and every line has a gradient. So that's what we need to find here. So, if we plug x equals 1 into dy by dx, we get 1 minus 5 over 3 times 1 to the power of 2 over 3 is equal to 1 minus 5 over 3, which equals negative 2 over 3. So then, what does our equation become? Well, our equation becomes y minus 0 is equal to negative 2 over 3 x minus 1. If we rearrange this now, we simply get 2x plus 3y is equal to 2. So this is perfect because it matches exactly what they wanted. Alright, so now we've got the last part of question 151. Find the area of the shaded region. Sounds straightforward, right? Just integrate it. But wait, there's a catch here. The shaded region isn't just one shape. It's actually just a triangle minus a curved bit. So we need to split this up. First, we have the easy bit, the area of the triangle. Now at face value, the area of the triangle is simply it's easy. It's just base times height divided by 2. But the issue here is that we have an unknown. Can you see what it is? We have the base. That's simply just 1. But our height is still a mystery. So how do we get this? Well, the height is achieved here by recognizing that all it equals is the y value of b. Knowing this, the question therefore becomes, how do we find the y value of b? Well, to find the y value of b, simply recognize that b is the intersection between the lines y equals x and 3y plus 2x equals 2. And so we can simply say from here that 3x plus 2x equals 2, which means therefore that x equals 2 over 5. So b naturally is going to equal x equals 2 over 5, y equals 2 over 5, which means our height in the triangle problem is 2 over 5 units. Now the slightly more tricky part would be the curve. Our curve is y is equal to x minus x to the power 5 over 3. And so to find the area under it, we just integrate. Okay, so if we do the integral of x minus x to the power 5 over 3 dx from 0 to 1, we get half x squared minus 3 over 8x to the power of 8 over 3, and that's all bounded between 1 and 0. Now, expanding this out, we therefore get a half minus 3 over 8 minus 0, which gives us 1/8 altogether. And so if we put this all together now, remember our total area is equal to the triangle area minus the curve area. Alright? And we know what the triangle area is, that's 1 over 5. We know what the curved area is, that's 1 over 8. And so if we crunch this all together, that's simply going to equal 1/5 minus 1/8, which gives us 3/40. That's our final area. Okay, so now moving on to question 152. We're told there's a point P is equal to 3k on the curve y is equal to x squared plus ax minus 4. And here we need to find both a and k given that the gradient at P is 3. Let's untangle this. If we start with P is equal to x equals 3k, we can say that if x equals 3, okay, and we plug that into our equation, then k is simply going to equal 9 plus 3a minus 4 is equal to 3a plus 5, okay, because we plugged it in. So far here, k depends on a. But here's the issue. We don't know a yet. All we know is that the gradient at P is 3. So, how do we get the gradient from a curve then? Well, this is when our derivatives kick in. Because we can say that, according to the equation, y is equal to x squared plus ax minus 4, dy by dx must therefore equal 2x plus a. Now at P, the gradient here is 3. And so if we plug in x equals 3, we get 3 is equal to 6 plus a, which naturally means that a must equal negative 3. Now if we loop all of this back, k is equal to 3a plus 5, which means that we get 3 times negative 3 plus 5 is equal to negative 4. As a result, our answer is therefore a equals negative 3, k equals negative 4. Just before you go, if you want to see more of these videos, make sure to head over to the Quick Maths platform and sign up in order to get preferential access to our platform before it drops. It costs nothing to sign up with your email, and once we're live, you'll get a massive discount. So I'll see you guys in the next one. Cheers, bye.